third grade students and families. Thank you for tuning in to BCPS-TV. Welcome to Week 6, Lesson 2 for April 20th to 24th. This video is to support schools using the Bridges Math program. My name is Miss Greenwood, and I'm so excited to connect with you all today. Materials that can support your learning today include pencils, scrap paper, and your Bridges Math packet. It's time to get this math party started. Let's go! Objective. Students will solve problems. I want you to think about yourself as a math learner. What helps you when you are solving math problems? What helps you to make sense of the problems that you are encountering? Maybe you like to read the problem more than once. Maybe you like to annotate or create labeled sketches to help you process what the problem is about. It's important to have some strategies when we're solving problems to help us persevere, especially when problems pose to be very challenging. So today, we're going to be solving problems that are going to involve, does anyone recognize this picture clue from our earlier lesson? We're going to be really thinking about problems that involve area. Remember, we were working with tiled rectangles and arrays to help us think about how that connects to area. Can you picture that tiled rectangle right now and how it has equal rows and equal columns? So we're going to be making sense of problems today involving area, because we want to see how area is used in the real world. Think about it. How many? Take a look at this picture. What do you notice? What do you wonder? As you think about this, here are some questions I want you to consider. What do you see that you can count? Can you count in different ways? Does the placement of the objects give you ideas? What groups do you notice? What equations could you write to describe how many? Jot down your thoughts, or if someone's nearby, turn and talk with that person about what you're noticing and wondering about this picture and the question, how many? We'll come back shortly to discuss. One way to answer how many is to count objects. Another way is to see the total right away. Thinking about different ways to count, looking for equal groups, and describing the total using words and symbols can deepen the math in your brain. So let me ask you, did you start counting the pull tabs? How many did you count? Did you notice that there's 6 pull tabs in all with 1 to the side? Did it make you think about 6 minus 1? Or did you notice there was a group of 5 and then one more and you thought about 5 plus 1? Maybe you noticed 2 holes in each of the tabs and started to count those. Did you notice that there are 12 holes altogether? Did you notice that there seems to be an empty space in the row of pull tabs? Like maybe there were 7 and 1 got taken away, so now there's only 6, or 7 minus 1 equals 6. Let's go and revisit this idea of counting the holes in the tabs, because this was something that I was starting to think about when I was studying the picture. So I noticed that there was a group of 5 pull tabs on the left with 2 holes in each of the tabs. So this made me think about 5 times 2. But then I know that there's another tab over here on the right, also with 2 holes in it. So now I'm thinking 5 times 2 plus 1 times 2 will tell me how many holes there are altogether. 5 times 2 is 10, plus 2 would then give me 12 holes. This is the type of thinking that we're going to be exploring later in the lesson when we get to distributive property. Learn about it. In our last lesson, we discussed that area is defined as the total number of square units needed to cover a two-dimensional surface, like when we want to recover our floors with new carpeting, or maybe we need to repaint the walls in a room. This would be all examples of two-dimensional surfaces where we would need to know the area of those spaces. So this brings us to our next part of our conversation when we talk about when area could come up in real-world problems and situations. So let's talk about the example of needing to buy a rug for your room. So this is our rug. You need to know the dimensions and the area of the rug so that you know how much space the rug will cover on the floor in your room. Let's say we find out that this rug is 2 feet by 4 feet. So I want you to picture those tiled rectangles that we were practicing before. I want you to picture 2 equal rows and 4 equal columns. Can you see it in your mind? Here's maybe what it looks like. Now let's figure out the area of the rug, or how many square units this rug will cover. 2 rows of 4 square feet is the same as 2 times 4. And I know that 2 times 4, or 2 groups of 4, would give me a total of 8. We could also think of this as 4 columns of 2 square feet, or 4 times 2. 4 times 2 equals 8. As we work with tiled rectangles today, let's imagine that they could be rugs for a room, or maybe the dimensions of a painting we want to hang on a wall. This will help us connect finding area with real-world connections. So here we have a tiled rectangle. Let's pretend this tiled rectangle is showing us the amount of floor space we have in a room. To find the area of this rectangular space, we would need to determine the dimensions of the room. To do this, we can count the number of rows, which happens to be 4 rows in this rectangle, and the number of columns, which happens to be 6. Now, how would you use these dimensions to help you find the area or total number of square units for this rectangle? Take a minute to think about that. So, did you count each of these square units individually? That's probably taking you a little bit of time to do. Or did you start thinking about groups of 6 because you were really paying attention to those rows of the rectangle? So maybe in your head, you started thinking about 6 plus 6 plus 6 plus 6 and how that equals 24. Or maybe you didn't think about the rows, but you went to the columns and you were noticing that there are 6 columns of 4 square units. So maybe you did 4 plus 4 plus 4 plus 4 plus 4 plus 4. Either way, you would get to 24 as your total number of square units. You can also represent this thinking using multiplication. Area can be calculated by counting the total number of rows and multiplying by the total number in each row. 4 times 6 equals 24 is also representing that same thinking that was taking place when you repeatedly added 6 4 times to get 24. You could also write 6 times 4 equals 24 to represent the 6 groups of 4 if you were thinking about the columns. Remember, area is the same as the number of rows times the number of columns. What do you notice? What do you wonder? So I'm noticing that we have an array or a tiled rectangle here. And I'm noticing that we have a multiplication expression or fact, 6 times 7. So what we're going to be exploring today is looking at how the distributive property can help us with calculating the area of tiled rectangles or arrays. Let's do one together to see what this property is all about and why it might be helpful for you to use to calculate area more efficiently. So let's start with how many rows does this tiled rectangle have? Well, using the math expression, I can quickly figure out that it has 6 equal rows. And so I'm going to go ahead and have that dimension labeled here on the side to show that there are 6 equal rows, or the length of this side is 6. Now we need to find out how many square units are in each of these 6 rows. And we can do that by counting the number of columns. 1, 2, 3, 4, 5, 6, 7. So the expression or multiplication fast fact represents our array or tiled rectangle here. Now, do you know 6 times 7 easily off the top of your head? Maybe this is a fast fact we haven't quite mastered yet, and that's perfectly okay. That's where the distributive property will come in handy. Let me show you how this will work. So when I use the distributive property, it helps me to think about my favorite numbers. These numbers are friendly in my mind because I can multiply them or think about equal groups more easily than other numbers. So 7 right now is not my friendly number, but I really like working with 5s. I can skip count pretty well in groups of 5, and even when I'm coming across math expressions with 5 as a factor, I know most of them. So I'm going to go ahead and break apart this 7 and think of it more as 5 plus 2 more is the same as 7. So what does this look like when we're working with an array? Well, here I can put a line segment to partition this rectangle to show here's a group of 5 columns, and here's the other 2 columns. 5 columns plus 2 columns is the same as 7 columns. So in terms of multiplying, it's going to be easier for me to start with multiplying 6 groups of 5, and then I can do 6 groups of 2. So 6 times 5, that's one I know pretty well, and I know that that product is 30. 6 times 2 is pretty easy for me too. 2 equal groups of 6, or 6 groups of 2, whichever way helps me think about it best, will get me to a product of 12. 6 rows times 5 columns plus 6 rows times 2 columns. 6 times 5 equals 30. 6 times 2 equals 12. Now we're going to put these 2 partial products together to come up with our final product or answer, which is 42. Didn't I tell you that this distributive property is cool? It's cool because it helps us break our array into smaller parts so that we can calculate the total area or number of square units more easily. Finding more small areas. So the rectangles below have already been filled with square units. For each pair of rectangles, we want to label the dimensions of the first one, multiply the dimensions to find the area and write an equation to match, break the second rectangle into two smaller ones, find the area of each of the smaller rectangles and add them, write equations to show your work. So let's work through these steps together to practice what we've been talking about all this week, which is finding the area of arrays, and now using the distributive property to break arrays into smaller rectangles to help us calculate the area more easily. So we're going to start with our first bulleted item here, label the dimensions of the first rectangle. So our first rectangle has 5 rows and 3 columns. And now we want to multiply these dimensions to find the area. So remember, rows times columns equals area. 5 groups of 3, or 5 times 3, is the same as 15. If you were thinking of this in terms of columns times rows, or 3 groups of 5, you could also write 3 times 5 is the same as 15. We're now going to break the second rectangle, which is the same as the first, into two smaller ones. Remember, this is to help us practice using the distributive property if we come across a factor or dimension where the number is not so friendly in our mind to multiply in our head. We're going to find the area of each of these smaller rectangles and add them, and we're going to record equations to represent that thinking that took place. So there's lots of ways we could break this array into smaller rectangles. We're going to do one way together. So here is where I'm breaking up the second rectangle into two smaller ones. And now I want to make note of how many rows are in each of these smaller rectangles. So there are 3 rows in the top rectangle and 2 rows in the bottom rectangle. This makes sense because before, in our first rectangle, there were 5 rows. 5 is the same as 3 plus 2. So now we want to note how many columns are in this, or in both rectangles, which is going to be the same number from the rectangle over here on the left, which is going to be 3. Now we want to find the area of each of the smaller rectangles. So 3 rows of 3, or 3 times 3, and 2 rows of 3, or 2 times 3. 3 times 3 plus 2 times 3. These parentheses are here to show that we're first finding the area of our top rectangle, 3 times 3. Then we're going to find the area of our second rectangle by multiplying 2 times 3. When we have both areas or products, then we will add them together. 3 times 3 is 9. 2 times 3 is 6. 9 plus 6 equals 15 square units. Let's do another one. Let's start with the rectangle on the left and labeling its dimensions. There are 5 rows and 6 columns. 5 groups of 6, or 5 times 6, is the same as 30 square units. Now let's go to the second rectangle on the right, and we're going to break it into 2 smaller ones. I'm going to go ahead and break it here. Now I can think of this as 5 rows of 2, or 5 times 2, plus 5 rows of 4, or 5 times 4. 5 times 2 gives me 10. 5 times 4 equals 20. 10 plus 20 equals 30 square. Now it's time to try it. you will go to your Bridges Math Packet and find 2 activities to complete and practice these skills we have been talking about. First, you will go to Areas to Find on page 182. Problem number 1 requires that you label each rectangle with its dimensions and find its area. Problem number 2 is going to involve working on finding products for the multiplication facts listed below. Your second page that you will do for practice is finding more small areas on page 185. Remember, we already did the first 2 problems for this activity, so you are doing problem number 2 at the bottom. When you are done practicing, it'll be time to show what you know. You will complete from your Bridges Math Packet Playing with Area on page 100. These will have some sample real-world problems where you will find area based on the information provided in the story problem. Well, 3rd grade students and families, I've had the best time with you all today, and I look forward to working with you next week. For now, stay safe and stay connected.